Hi, I'm Kathy Manley. This video covers Lesson 3, Happy Maps from Course A. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 1, Safety in My Online Neighborhood, Lesson 3, Happy Maps that we're covering today, and Lesson 4, Sequencing with Scrat that we will cover next. There are awesome additional lessons that you may also want to do with your students, so we encourage you to explore the course. Lesson 3 was designed to help kids learn about algorithms, the steps to solve a problem. This lesson provides many opportunities to develop computational thinking skills. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, and to share pedagogical strategies for implementing the lesson. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. We will focus on decomposition, algorithm, and debugging as shown in bold. For more detailed information, you can watch the Computational Thinking Concepts and Powerful Ideas videos on our website. Students will also use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I will walk you through this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. And lastly, we will focus on the process of problem solving. The warm-up activity provides an opportunity to introduce many of the computational thinking skills. First, the students will use problem solving. They need to understand that the problem they are trying to solve is how to help you get from your location to the board. Then they need to plan a solution. Students will decompose the steps needed. Once the students come up with their plan, ask them if the sequence, the order of the steps, matters. Take the students through their PRIM approach. What will happen if you follow the set of instructions, the algorithm? Run the program by following their steps and ask them to observe or investigate as you follow the steps. Did their steps get you to the board? If not, what do they need to modify? Ask them if there was only one way to get from where you were to the board. You could then put students into small groups and have each group develop the instructions to get you from a more complicated place that requires you to go around obstacles. The video will introduce the main activity with flurbs and fruit. Throughout the main activity, reinforce the vocabulary, discuss the sequence of the steps, introduce the term debugging, have the students compare and contrast the warm-up activity with the flurb and fruit activities. Let the students know that they are developing codes and are taking the first step in writing programs or algorithms for a computer to follow. But most of all, give students time to play, think, and code while working on critical thinking and problem-solving skills. Then wrap up by comparing and contrasting an algorithm and a program and talking with the students about what they learned in this lesson. There are also some great extended learning activities at the end of the lesson, so be sure to investigate the lesson plan that is online.